Imagine if you could gather up all the energy from every single star within 100 million light from thousands of galaxies, each with billions of stars. Now imagine you could take all of that power and use it to fire the biggest superweapon in the universe. Think of the damage you could do. Well, you don't need to imagine it. These things exist, and they're called gamma-ray bursts. So, what are these cosmic snipers? And more importantly, what would happen if one took a shot at Earth? To understand gamma-ray bursts, we first have to understand gamma ray. Gamma rays are a type of electromagnetic radiation waves that carry energy, just like the visible light our eyes can see. But visible light is just a tiny sliver of the full electromagnetic spectrum. At lower energies, you have radio waves, microwaves, and infrared. And at higher energies, you get ultraviolet, X-rays, and the most powerful of all, gamma rays. Gamma rays are incredibly energetic. A single gamma-ray photon has more energy than 1,000,000 visible light photons combined. Their high energy makes them a form of ionizing radiation, which means they're powerful enough to literally break apart atomic bonds. This is what makes them so dangerous to living things. Ionizing radiation tears through the delicate biochemical machinery that keeps us alive, like a bullet through a fine-tuned clock. Thankfully, here on Earth, our atmosphere, specifically the ozone layer, acts as a shield, blocking these harmful gamma rays from space before they can reach us. But wait, if our atmosphere blocks them, how did we ever discover gamma-ray bursts, or GRBs, in the first place? The story starts during the Cold War. The United States launched spy satellites designed to detect gamma rays from any secret Soviet nuclear tests in space. They never found any bombs, but they did observe something strange. Faint, random bursts of gamma rays coming from deep space, lasting only a few seconds. This might just be the only major scientific discovery made by spy satellites, at least, that we know about. For 30 years, these bursts were a complete mystery. Astronomers used different kinds of light to see the universe, and these satellites had just given them a new, powerful pair of eyes. Eventually, they tracked down the source of one of these GRBs, a galaxy 6 billion light-years away. For a burst to be visible from that incredible distance, it must be unbelievably powerful. In fact, a typical GRB releases more energy in a few seconds than our sun will in its entire 10 billion-year lifetime. This makes GRBs the single brightest and most energetic events in the entire universe. So, where does all this energy come from? GRBs are born from some of the most violent, cataclysmic events the cosmos has to offer, specifically the death of massive stars and the birth of black holes. There are two main types of gamma-ray bursts: long and short. Long GRBs, which can last for about a minute, are thought to come from hypernovae. This is when the core of a truly massive star collapses under its own gravity, forming a brand new black hole. Short GRBs, lasting just a second or two, are produced by an even more exotic event: the merger of two neutron stars. These are the ultra-dense remnants of dead stars, locked in a cosmic dance. Over millions of years, they spiral closer and closer, finally crashing into each other with unimaginable force, and you guessed it, forming a black hole. In both cases, you end up with a newborn black hole surrounded by a spinning, magnetized disk of superheated gas. The black hole's intense rotation winds up these magnetic fields, creating and launching two incredibly narrow, focused jets of particles traveling at nearly the speed of light. These jets are what create the tight beams of high-energy gamma rays, like a celestial laser gun. Unlike a typical explosion that spreads out in all directions, these focused jets can travel across billions of light-years and still be detected. The universe is literally filled with these cosmic snipers, firing blindly and randomly into the dark. And believe it or not, they're hitting us all the time. On average, our satellites detect one GRB every single day. Fortunately for us, almost all of these bursts have originated in galaxies far, far away, too distant to cause any harm. But what if one happened closer to home? A nearby GRB would be catastrophic. If one went off within a few light years of us and was pointed our way, it would completely cook the surface of the Earth. Or at least, the half of it that was facing the blast. But even a more distant, GRB could still spell doom for life on Earth. It wouldn't need to score a direct hit to be lethal. If a burst originated a few thousand light-years away, its beam would be 100 light-years wide by the time it reached us, washing over our entire solar system like a cosmic tidal wave. Again, our ozone layer is our primary defense, but it's designed to handle the steady, gentle stream of radiation from our sun. A full-on blast from a gamma-ray burst would completely overwhelm it, stripping it away and leaving us exposed to the sun's deadly radiation. Ozone takes years to replenish naturally. That's more than enough time for the unfiltered sun to burn the Earth's derail, wiping out most complex life. In fact, some scientists think this may have already happened. A gamma-ray burst has been proposed as a possible cause for the Ordovician-Silurian extinction event, which happened 450 million years ago and wiped out about 85% of all marine species. Of course, it's nearly impossible to prove after so much time has passed. The threat of GRBs could even be one of the answers to the Fermi paradox, the question of why we do UNC, signs of intelligent life elsewhere in the universe. It's possible that these bursts periodically sterilize huge chunks of the cosmos, resetting the clock on life. Some estimates suggest that because of GRBs, only about 10% of all galaxies might be hospitable to complex life like us. So, the big question: are we all going to be zapped by a gamma-ray burst? Probably not. Probably not. In a galaxy like the Milky Way, GRBs are thought to be incredibly rare, maybe happening once every few millennia. And for one to harm us, it has to be relatively close and pointed directly at us. The odds are very low, but here's the unsettling part. Gamma rays travel at the speed of light. That means we would have no warning whatsoever. We wouldn't see it coming. There could be a death ray from a collapsing star already rocketing across the cosmos, aimed directly at our planet. We'd have no idea until the moment it hits us. Thank you so much for watching. If you enjoyed this journey into the most powerful explosions in the universe, don't forget to hit that like button and subscribe for more cosmic content. See you in the next one.